Something is stirring in the dark, frozen edges of our solar system, something massive, unseen, and utterly mysterious, far beyond Neptune, where sunlight is little more than a faint glimmer. A handful of icy objects are moving in ways they shouldn't. Their paths are twisted, pulled by something we can't see, something that defies all our current maps of the cosmos. This isn't just a scientific curiosity, it's a cosmic detective story, one that could rewrite everything we thought we knew about our own celestial neighborhood. And today, we're diving deep into the evidence that's got astronomers buzzing. 22 peculiar objects in the Kuiper Belt, each one tracing a bizarre trajectory that points to the existence of a hidden giant. Picture this: you're standing on the shore of an endless ocean, staring at the waves. Suddenly, you notice a pattern, a ripple that doesn't match the wind, a current that bends in ways it shouldn't. That's exactly what scientists are seeing in the Kuiper Belt. These distant, frozen worlds, some no bigger than cities, are drifting along paths that can't be explained by the gravity of the planets we already know. It's as if an invisible hand is nudging them off course, and the only explanation, a hidden world lurking in the shadows, so far away that even our most powerful telescopes can't spot it. This isn't science fiction, it's real, it's happening right now, and it could be one of the biggest astronomical discoveries of our time. What if I told you that our solar system might still have secrets this colossal, that after centuries of mapping the heavens, we could be on the verge of finding a planet-sized ghost, quietly shaping the orbits of everything around it? The implications are staggering. A hidden giant wouldn't just be another icy rock in the void. It could redefine our understanding of how planetary systems form, how they evolve, and even where life might exist. So buckle up, because we're about to explore the mind-bending science behind these 22 mysterious objects, the cutting-edge theories trying to explain them, and the thrilling hunt for whatever's out there, waiting to be found. By the time we're done, you'll never look at the night sky the same way again. The Kuiper Belt is more than just a distant ring of frozen debris. It's a time capsule, preserving the raw ingredients of our solar system's birth over 4 billion years ago. Stretching from Neptune's orbit out into the blackness, this vast frontier is where worlds like Pluto and Eris reign as dwarf planets, surrounded by trillions of smaller icy bodies. But here's the twist: these objects aren't just floating aimlessly, they move with purpose, their orbits sculpted by gravity. And recently, astronomers noticed something strange. Among the countless chunks of ice and rock, 22 stand out, tracing paths that bend in ways our current models can't explain. It's as if an unseen force is tugging at them, a shadowy presence warping their trajectories. Think of it like a game of cosmic billiards. When you see a ball suddenly change direction without being hit, you know something's off, maybe an invisible magnet beneath the table. That's exactly what's happening here. These 22 objects aren't following the rules. Their orbits tilt at odd angles, cluster in unexpected ways, or stretch farther out than they should. The math says there's only one plausible explanation: a hidden planet, at least 5 times the mass of Earth, lurking in the darkness. And it's not just any planet, it's a ghost world so distant that even a single orbit around the Sun could take 10,000 years. What makes this discovery so thrilling isn't just the possibility of a new planet, it's the way it challenges our understanding of the solar system's architecture. For decades, we assumed the outer reaches were quiet, predictable. But these oddball orbits suggest chaos, a gravitational fingerprint left by something massive we've yet to lay eyes on. The hunt is already underway, with astronomers scouring the sky for the faintest glimmer of reflected sunlight. Every new telescope, every upgraded instrument brings us closer to spotting this elusive giant, if it's really out there. Until then, those 22 rebellious objects keep whispering the same tantalizing question. What else is hiding in the dark? The first clue came not from what astronomers could see, but from what they couldn't explain. Out in the frozen expanse of the Kuiper Belt, far beyond the familiar planets, a handful of icy objects were breaking the rules. These weren't just random rocks drifting lazily through space. Their orbits were tilted, stretched, and clustered in ways that defied every model of our solar system's gravity. Picture a flock of birds suddenly veering off course, not because of the wind, but because of something massive lurking just below the horizon. That's exactly what scientists observed. 22 objects all dancing to the same mysterious tune, their paths warped by an invisible conductor. Take Sedna, for example, a small, reddish world discovered in 2003. Its orbit is a cosmic oddity, stretching so far out that at its most distant point, it's nearly 1,000 times farther from the Sun than Earth. Even stranger, it shares this bizarre path with several other Kuiper Belt objects, all tilted at roughly the same angle. The odds of this happening naturally. Astronomers calculate it's less than 1 in 100. That's like flipping a coin 10 times and getting heads every single time possible, but so unlikely that you'd start suspecting the coin was rigged. Then there's the clustering. These 22 rebels don't just have odd orbits, they're grouped together in a way that suggests they're being herded. Imagine tossing a handful of marbles onto a trampoline. If left alone, they'd roll randomly toward the edges. But if someone hidden beneath the fabric reached up and gently pushed, you'd see them gather in one spot. That's the kind of gravitational fingerprint scientists are tracking, the only force strong enough to orchestrate this celestial choreography, a planet. Not just any planet, but one with up to 10 times the mass of Earth, lurking so far out that its gravitational whispers take centuries to reach us. This isn't the first time astronomers have predicted a planet's existence before seeing it. In the 1800s, irregularities in Uranus's orbit led to the discovery of Neptune, a triumph of celestial math. But here's the twist: Neptune's gravity can't explain these Kuiper Belt anomalies. Whatever's out there is farther, darker, and far more enigmatic. Some theorists suggest it could be a rogue planet captured by our sun's gravity long ago. Others wonder if it's a primordial relic, a frozen giant left over from the solar system's violent birth. The hunt is now a race against time and technology. Every new telescope, like the Vera Rubin Observatory set to scan the skies in 2025, brings us closer to spotting this cosmic phantom. Until then, those 22 wayward objects keep tracing their cryptic paths, each one a breadcrumb leading deeper into the dark. And if history teaches us anything, it's that when the universe leaves clues this bold, the truth is bound to be extraordinary. Sedna isn't just another frozen world drifting in the void. It's an enigma wrapped in ice, a celestial rebel with an orbit so extreme it defies belief. Imagine a planetoid so far-flung that its journey around the Sun takes longer than all of recorded human history, 11,400 years. At its farthest point, it ventures over 900 times the distance between Earth and the Sun, plunging into such profound darkness that our star would appear as little more than a bright pinprick. But here's what really baffles scientists: Sedna isn't alone. It shares this outrageous path with other oddballs like 2012 VP-113, nicknamed Biden after its discovery year. Together, these cosmic outliers form a pattern so peculiar that chance alone can't explain it. Think of these objects as celestial breadcrumbs, each one leading us toward the same unsettling conclusion. Their orbits aren't just stretched, they're tilted, clustered, and aligned in a way that screams interference. It's like watching a group of skaters gliding across a frozen pond, only to suddenly veer in unison toward a single spot on the ice. No wind, no slope, just an unseen force pulling them off course. For astronomers, this isn't a coincidence. It's a gravitational signature. Something massive, something distant, is herding these objects into their strange configurations. The math behind this is even more compelling. When researchers modeled the orbits of Sedna and its kin, they found the odds of this alignment happening naturally were less than 0.02%. That's like shuffling a deck of cards and dealing yourself a perfect royal flush repeatedly. The only plausible explanation: a hidden planet, at least 5 times Earth's mass, orbiting so far out that its gravitational influence moves at a glacial pace. Unlike the orderly, flat plane where most planets reside, this phantom world would likely trace a wild, inclined orbit, its gravity reaching across billions of miles to sculpt the paths of these icy wanderers. What's fascinating is how this mirrors history. When Neptune was discovered in 1846, it wasn't by accident astronomers predicted its existence based on Uranus's wonky orbit. Now we're seeing the same clues play out in the Kuiper Belt, but with a twist. Neptune's gravity can't account for these anomalies. Whatever's out there is bigger, farther, and far more mysterious. Some theories suggest it could be a rogue planet, ejected from another star system and captured by our sun's gravity. Others propose it's a primordial giant, flung outward during the solar system's chaotic infancy. The hunt for this hidden world isn't just about adding another planet to our chart. It's about rewriting the story of our cosmic neighborhood. If it exists, Planet 9 would challenge everything we thought we knew about how planetary systems form and evolve. And while telescopes haven't yet spotted it, the evidence keeps mounting. Every new discovery, every odd orbit mapped, tightens the noose around this cosmic ghost. Until we catch a glimpse, Sedna and its mysterious kin remain the most tantalizing clues in the greatest treasure hunt the solar system has ever seen. Numbers don't lie, and in the case of these 22 rebellious Kuiper Belt objects, the math is shouting something extraordinary. When astronomers fed the bizarre orbital data into supercomputer simulations, something remarkable happened. The only way to make sense of those clustered, tilted paths was to introduce an invisible player, a planet 5 to 10 times more massive than Earth, orbiting hundreds of times farther from the Sun than we do. Picture a cosmic game of connect the dots, where the only way to complete the picture is by adding a colossal, unseen world lurking in the shadows. These simulations aren't just guesswork, they're precise, gravitational detective stories. Every odd tilt, every unexpected cluster in the Kuiper Belt object's orbits can be traced back to the gentle but persistent tug of this hypothetical giant. The calculations suggest it follows an elongated, tilted orbit of its own, swinging so far out that a single trip around the Sun could take between 10 and 20,000 years. At that distance, sunlight would be virtually non-existent, rendering the planet nearly invisible to our telescopes, but its gravitational fingerprint would be unmistakable. Here's where it gets even more compelling. When researchers removed this theoretical planet from their models, the simulations fell apart. The Kuiper Belt object's orbits suddenly became random, scattering like marbles dropped on a floor. But reintroduce that hidden world, and everything snaps into place: the peculiar clustering, the shared orbital angles, the stretched paths. It's like finding the missing piece of a jigsaw puzzle that makes the entire image coherent. Critics argue that extraordinary claims require extraordinary evidence, and they're right. but the math behind this prediction is robust, echoing the same methods that led to Neptune's discovery. Back then, astronomers didn't see Neptune first. They calculated its existence based on Uranus's wonky orbit. Today, we're seeing history repeat itself, but on a far grander scale. The difference this time, the hidden world isn't just another ice giant next door. It's a potential super-Earth lurking in the solar system's darkest reaches, rewriting the rules of what we thought was possible. What's thrilling is how precise these predictions are. The simulations narrow down the possible location of this phantom planet to a rough swath of sky, giving astronomers a cosmic haystack to search. Telescopes are already scanning these regions, hunting for the faintest glimmer of reflected sunlight, a needle in a stellar haystack. Until then, the math stands as one of the most tantalizing clues in modern astronomy, a silent testament to the idea that our solar system still holds secrets waiting to be uncovered. Neptune has always been the solar system's quiet giant, calm, predictable, and content to drift in the cold outer reaches. But something about its orbit has never quite added up. For decades, astronomers have noticed tiny irregularities in its path, subtle wobbles that shouldn't exist if our current map of the solar system is complete. It's as if Neptune is being tugged by an unseen hand, gently pulled off course by something massive lurking just beyond our line of sight. And here's the kicker: those discrepancies match eerily well with the gravitational signature of a hidden planet. The first hints of this anomaly came from an unlikely source, the Voyager 2 spacecraft. When it flew past Neptune in 1989, it provided the most precise measurements ever of the ice giant's position and motion. But when scientists crunched the numbers, they found something odd. Neptune wasn't exactly where their models predicted it should be. The difference was minuscule, just a fraction of a degree over decades. But in the ultra-precise world of celestial mechanics, even the tiniest deviation speaks volumes. It's like noticing a clock that's off by a few seconds every year, small but undeniable proof that something's not quite right. Modern telescopes have only deepened the mystery. Observations from Earth and space reveal that Neptune's orbit isn't the only one acting strangely. Uranus, too, shows faint irregularities, as if both worlds are responding to the same unseen force. The most plausible explanation: a distant, massive object, its gravity subtly warping the paths of these planets over centuries. The effect is faint, like a whisper in a hurricane, but it's there, and it matches the kind of influence a hidden giant would exert. What's fascinating is how this mirrors history. In the 1800s, astronomers noticed Uranus wasn't following its predicted path, a discrepancy that led directly to Neptune's discovery. Now we're seeing the same story play out again, but this time Neptune itself is the one behaving oddly. The implications are staggering. If a hidden planet is tugging on Neptune, it would need to be enormous, far larger than Earth, and orbiting so far from the Sun that its gravitational nudge takes millennia to fully manifest. Critics argue these wobbles could be artifacts of measurement error or incomplete data, but the evidence is mounting. When you combine Neptune's irregularities with the bizarre orbits of those 22 Kuiper Belt objects, the case for a hidden world grows stronger. It's not just one clue, it's a web of them, each reinforcing the other. And while we haven't yet spotted this cosmic ghost, the math keeps pointing us in the same direction, outward into the dark, where something vast and unknown waits to be found. The search for Planet 9 isn't just a scientific endeavor, it's a high-stakes cosmic treasure hunt, with astronomers racing against time, distance, and the sheer vastness of space. Picture trying to spot a single, dim light bulb hidden somewhere in a desert the size of Earth, and you'll start to grasp the challenge. But this isn't a shot in the dark. Teams around the world are deploying some of the most advanced telescopes ever built, like the Subaru telescope in Hawaii, with its massive mirror designed to capture the faintest glimmers of light from the edge of our solar system. Then there's the Vera Rubin Observatory's Legacy Survey of Space and Time, or LSST, set to begin scanning the skies in 2025. This powerhouse will photograph the entire southern sky every few nights, creating a time-lapse map of the cosmos that could finally reveal the subtle movement of a hidden world against the backdrop of stars. What makes this search so daunting isn't just distance, it's darkness. A planet this far out would reflect almost no sunlight, making it billions of times dimmer than Jupiter or Saturn. To spot it, astronomers aren't just looking for a dot of light. They're hunting for a ghostly whisper of motion, a single pixel shifting imperceptibly over months or even years. It's like trying to track a snowflake drifting through a blizzard. But here's where technology turns the impossible into the merely difficult. Modern telescopes equipped with hypersensitive cameras can detect light so faint it's practically theoretical. Algorithms sift through mountains of data, flagging anything that moves in ways artificial satellites or asteroids don't. And with each passing year, the search zone narrows. The strategy isn't random either. Scientists have used the odd orbits of those 22 Kuiper Belt objects to triangulate possible locations for Planet 9, narrowing the hunt to a swath of sky roughly 20 times the width of a full moon. It's still a colossal area, but it's a start. Some researchers even suggest the planet could be closer than we think, not in the expected distant orbit, but hiding in plain sight, camouflaged by the glare of the Milky Way. Others propose it might be darker than predicted, covered in exotic ices that absorb rather than reflect light. One thing's certain, the discovery, if it happens, won't be accidental. It'll be the result of meticulous calculation, relentless observation, and a bit of luck. And when, or if, we finally spot this cosmic phantom, the moment will rewrite astronomy textbooks. Until then, the hunt continues, a testament to human curiosity and our unshakable belief that the universe still has secrets left to share. The idea of a hidden giant planet is thrilling, but science demands we consider every possibility, even the less glamorous ones. Some researchers argue the strange orbits of these Kuiper Belt objects might not point to a new world at all, but to ancient cosmic events. One compelling alternative suggests a rogue star, passing uncomfortably close to our solar system billions of years ago, could have yanked these icy bodies into their odd configurations. Think of it like a stone thrown into a pond. The gravitational ripples from that stellar visitor might still be visible today, frozen in the skewed paths of Sedna and its kin. Then there's the swarm hypothesis. Instead of one massive planet, perhaps countless smaller objects, undiscovered dwarf planets, or even a dense cloud of distant rocks collectively exert enough gravity to nudge these orbits. It's the difference between feeling a single strong magnet pull you and being surrounded by hundreds of tiny ones, each adding a subtle tug. The math shows this could technically work, but there's a catch. We'd need an implausibly large number of unseen objects packed tightly together in just the right way. It's like trying to balance a pencil on its tip, possible but so unlikely that a hidden planet starts to seem simpler. Others point to observational bias. Could we be seeing patterns where none exist? After all, spotting Kuiper Belt objects is like finding needles in a haystack. We've only catalogued a fraction of them, and most discoveries happen to cluster in regions where telescopes are pointed. It's a fair critique, but here's the problem. The odd orbits we've detected aren't randomly scattered. They're aligned with eerie precision, like compass needles all pointing northwest. Chance might explain one or two outliers, but 22, the odds defy logic. The hidden planet theory still holds one ace: predictive power. When astronomers plugged its hypothetical mass and orbit into simulations, the models spat out eerily accurate recreations of the real Kuiper Belt's chaos. Alternative explanations, while creative, often require stacking too many uncertainties. A passing star leaves no trace today. A swarm of unseen objects feels like inventing new mysteries to solve an old one. And while bias is always a concern, it can't account for the sheer consistency of these orbital oddities. That's not to say the debate is over. Science thrives on skepticism. But with every new observation, the scales tip further towards something monumental hiding in the dark. Until we spot it or rule it out conclusively, the universe keeps us guessing, dangling clues just out of reach. Computer simulations are the unsung heroes of this cosmic mystery, virtual laboratories where astronomers can bend the laws of physics to their will, testing theories without ever leaving Earth. Imagine building a digital replica of our entire solar system, then hurling a hidden planet into its outer reaches to watch the chaos unfold. That's exactly what researchers are doing, running thousands of simulations to see which version of Planet 9 best explains the real-life oddities in the Kuiper Belt. These aren't just video game recreations. They're precision-crafted models that account for everything from the gravitational pull of distant stars to the gentle nudge of interstellar gas. And the results are startlingly consistent. Only the presence of a massive, unseen world can recreate the bizarre orbital patterns we observe. Take one groundbreaking study from Caltech, where scientists fed the peculiar orbits of those 22 Kuiper Belt objects into a supercomputer. They tweaked variables like the hidden planet's mass, distance, and orbital tilt, then hit play to watch billions of years of cosmic evolution unfold in mere hours. Time and again, the same scenario emerged: a planet roughly 5 to 10 times Earth's mass, tracing a stretched, tilted path around the Sun, would sculpt the Kuiper Belt into the exact shapes we see today. It's like finding the missing ingredient in a recipe. Once added, the dish finally tastes right. Without this phantom world, the simulations spit out a scattered, random Kuiper Belt that looks nothing like reality. What's fascinating is how these digital experiments reveal the hidden planet's long-term influence. Gravity works slowly at such vast distances, so the simulations show how subtle tugs over eons could herd objects like Sedna into their peculiar orbits. Picture a shepherd guiding sheep with gentle calls, except here, the calls are gravitational whispers spanning millennia, and the sheep are icy worlds light years away. The models even predict where more of these oddball objects should be hiding, giving astronomers new targets to search. But simulations aren't just confirming the hidden giant theory, they're refining it. Early guesses placed Planet 9 hundreds of times farther from the Sun than Earth, but newer models suggest it might be closer, brighter, and easier to spot than we thought. Some runs hint it could be trapped in a gravitational sweet spot, looping between two stable points in space like a pendulum. Others explore wilder ideas, like the possibility it's not a planet at all, but a primordial black hole, its gravity warping orbits without emitting light. The beauty of these simulations is their flexibility. They let scientists ask, what if, on a cosmic scale, testing alternatives without dismissing them outright. Maybe a passing star did twist the Kuiper Belt's orbits long ago, but the models show such an event would leave other, observable scars we haven't found. Perhaps a swarm of small objects is responsible, but the math requires so many unseen bodies that a single planet starts to seem elegant by comparison. Every scenario gets its day in court, weighed against the evidence. As telescopes grow more powerful, these digital experiments act as a roadmap, narrowing the search to the most promising patches of sky. They've transformed Planet 9 from a wild guess into a precise prediction, complete with estimated size, orbit, and even reflectivity. It's a triumph of modern astronomy, using code and computation to shine light on the darkest corners of our solar system. And if the simulations are right, we're not just chasing a ghost, we're on the verge of meeting a new neighbor. History has a way of circling back, and when it comes to hunting hidden planets, the past might be our best roadmap. The discovery of Neptune in 1846 wasn't luck, it was celestial detective work at its finest. Astronomers had noticed Uranus, then the solar system's outermost known planet, wasn't moving as predicted. Its path wobbled slightly, as if something massive was tugging at it from the shadows. Two mathematicians, Urbain Le Verrier and John Couch Adams, independently crunched the numbers and predicted exactly where an unseen planet should be. When Johann Galle pointed his telescope to that precise patch of sky, there it was, Neptune, gleaming in the darkness, right where the math said it would be. Fast forward to today, and the parallels are impossible to ignore. Just as Uranus's odd orbit hinted at Neptune's existence, Neptune itself, along with those 22 rebellious Kuiper Belt objects, is now whispering clues about something even farther out. The math is eerily similar: unexplained gravitational nudges, orbits that don't add up, and a growing consensus that only a hidden world could explain the chaos. Back then, skeptics doubted Le Verrier's calculations until the moment Neptune materialized in the eyepiece. Now, the same skepticism meets Planet 9, even as the evidence piles up. But here's where the stories diverge. Neptune was relatively close, just a stone's throw beyond Uranus in cosmic terms. Planet 9, if it exists, would be orders of magnitude more distant, lurking so far out that its gravitational influence unfolds over millennia, not years. Finding it wouldn't just be a repeat of history, it'd be history dialed up to 11. Imagine Le Verrier's challenge, but with the added difficulty of searching for a planet that could be 20 times fainter than Pluto, moving imperceptibly against a backdrop of fixed stars. Yet the lesson of Neptune isn't just about persistence, it's about humility. Before its discovery, astronomers assumed our solar system was fully mapped. Neptune's sudden appearance was a reminder that the universe delights in surprises. Today, we're arguably even more confident in our cosmic census, with probes like Voyager and New Horizons sketching the edges of our neighborhood. But those 22 oddball orbits are a splash of cold water, a wake-up call that we might still be missing something monumental. If Planet 9 is real, its discovery wouldn't just mirror the Neptune story, it would eclipse it. Neptune was the 8th planet. This would be the 9th, reclaiming Pluto's lost number in a poetic twist. More importantly, it would redefine the scale of our solar system, proving that even in an age of space telescopes and interplanetary missions, the cosmos still holds cards close to its chest. Until we spot it, the ghost of Neptune's discovery lingers, a tantalizing reminder that sometimes the universe writes its own sequels. Finding a hidden planet at the edge of our solar system isn't just a needle in a haystack challenge, it's like searching for a single speck of soot in a pitch-black warehouse using a flickering candle. The biggest hurdle, light, or rather the lack of it. At those mind-bending distances, sunlight is so feeble that even a planet 10 times Earth's mass would reflect almost none of it back to us. Picture holding a dim, gray pebble at arm's length under a full moon. That's roughly how visible this world would be to our telescopes. And if it's cloaked in dark, primordial ices, as some theories suggest, it could be absorbing what little light touches it, turning it into a cosmic black hole in all but name. Then there's the problem of movement. Most planets betray their presence by shifting against the starry backdrop over weeks or months. But something orbiting hundreds of times farther out than Earth. Its motion would be glacial. Imagine watching the hour hand of a clock. You'd stare for ages before noticing any change. Now scale that to celestial distances. This object might crawl less than 1 arcsecond per year across the sky, a near imperceptible drift lost in the noise of twinkling stars. Even our most sensitive telescopes struggle to spot something so sluggish, especially when it's competing with the dense star fields of the Milky Way's galactic plane. That region is like Times Square at night, a riot of lights where picking out one faint, slow-moving dot becomes a Herculean task. Compounding the challenge is the sheer vastness of the search area. Early estimates suggested Planet 9 could be anywhere along an orbit spanning up to 600 times Earth's distance from the Sun. That's a cosmic haystack stretching a quarter of the way to the next star system. To cover that much ground, astronomers have to play a painstaking game of celestial connect the dots, stitching together images taken months or years apart, hunting for the faintest speck that isn't where it should be. It's like trying to reconstruct a burglar's path using only a handful of blurry security stills, except the burglar might take 20,000 years to complete one lap around the neighborhood. Technology, though, is turning the tide. Instruments like the Subaru telescope's hyper-subprime cam can image swaths of sky the size of 40 full moons in a single shot, while AI algorithms sift through petabytes of data for telltale movements. The upcoming Vera Rubin Observatory will up the ante, scanning the entire southern sky every few nights with a resolution so sharp it could spot a golf ball on the moon. These tools are rewriting the rules of the hunt, but patience remains key. After all, Neptune took 65 years to find after its gravitational fingerprints were first noticed. If history's any guide, the universe reveals its secrets only when it's good and ready. Until then, every unremarkable pixel in the data holds the tantalizing possibility of being the one that changes astronomy forever. Theories about Planet 9's origins read like a cosmic whodunit, with astronomers piecing together clues that could rewrite our solar system's history. One leading idea suggests this hidden giant wasn't always an outcast. It might have formed much closer to the Sun, alongside the other planets, before a gravitational showdown sent it hurtling into the abyss. Picture a game of planetary pinball in the early solar system, where Jupiter's immense gravity could have acted like a cosmic slingshot, flinging a fledgling Planet 9 outward with enough force to strand it in the frozen fringes. This wouldn't be unprecedented. Simulations show young gas giants often played rough, reshaping orbits and ejecting smaller rivals in their chaotic youth. But there's a twist. What if Planet 9 isn't even from around here? Another camp argues it could be an interstellar interloper, a rogue planet captured by the Sun's gravity as it drifted through the galaxy. Stars form in dense clusters, passing close enough to swap planets like trading cards. If our Sun had a close encounter with another star billions of years ago, it might have stolen a world right out of its neighbor's backyard. The telltale sign, Planet 9's extreme tilted orbit, a hallmark of celestial kidnapping, would look entirely different from the orderly paths of planets born here. Then there's the wild card, primordial black holes. A handful of theorists suggest this mysterious gravitational influence might not be a planet at all, but a grapefruit-sized black hole left over from the Big Bang, its dense core warping space-time just like a planet would. While far-fetched, the idea isn't impossible. Such objects could be lurking undetected throughout the galaxy, their darkness making them near invisible. The implications of any of these scenarios are staggering. If Planet 9 was exiled from the inner solar system, it means our cosmic neighborhood was far more violent than we thought, with planets jostling for position like marbles in a tornado. If it's a captured alien world, it's proof our Sun has a history of cosmic theft, snatching worlds from passing stars. And if it's something even stranger like a black hole, it would force us to rethink the very fabric of our solar system. What's clear is that Planet 9 isn't just a missing puzzle piece, it's a key to understanding whether our solar system's calm, orderly present is the exception or the rule. Every strange orbit in the Kuiper Belt, every unexplained wobble in Neptune's path, whispers the same tantalizing question: how many times has the universe rewritten the story of our celestial home without us even noticing? If Planet 9 is real, it wouldn't just be another world to add to the solar system's roster. It would be a time capsule holding secrets about our cosmic backyard's most chaotic era. Picture the early solar system not as the orderly place we know today, but as a demolition derby of protoplanets, gas giants, and swirling debris. In that primordial free-for-all, a planet like this could have been the bull in the china shop, its gravity rearranging everything in its path. One of the biggest mysteries it might solve, the Sun's peculiar tilt. Unlike most stars whose spin aligns neatly with their planet's orbits, our Sun leans at a slight 6-degree angle. For decades, astronomers scratched their heads over why, until simulations showed a distant, massive object could have yanked the entire solar system off kilter like a misaligned bicycle wheel. But the implications run deeper. The Kuiper Belt's strange orbits aren't the only anomalies. Take the so-called inclination problem. Many distant objects orbit at steep angles, defying expectations that they should all line up like marbles on a flat table. A hidden planet's gravity could act like a cosmic sculptor, nudging these icy bodies into their odd configurations over billions of years. Even more intriguing is the possibility that Planet 9 isn't alone. Some models suggest it could have siblings, other exiled worlds flung outward during the solar system's violent youth, now lurking in the dark. Then there's the grandest question of all: how common are solar systems like ours? Most exoplanet discoveries reveal worlds packed close to their stars, with nothing resembling our distant, sparse outer reaches. If Planet 9 exists, it might be the key to understanding why our cosmic neighborhood looks so different. Perhaps its presence stabilized the outer solar system, preventing other planets from spiraling inward or being ejected entirely. Or maybe it's a relic of a rarer, more dynamic planetary formation process, one where gravitational tugs of war left survivors scattered across vast distances. The discovery wouldn't just fill a gap in our maps, it would rewrite the story of how planetary systems grow up. Imagine finding a lost chapter of a book you thought you knew by heart, one that changes the meaning of everything that came before. That's the scale of what's at stake here. Every odd orbit, every tilted path, every unexplained wobble is a clue waiting to be deciphered, a whisper from the solar system's wildest days. And if we're right about Planet 9, those whispers are about to become a roar. The idea of an undiscovered planet lurking in our solar system's shadows taps into something deep in the human psyche, a mix of wonder, curiosity, and maybe even a hint of primal fear. It's no surprise that Planet 9's hypothetical existence has sparked imaginations far beyond the scientific community, giving rise to wild theories and doomsday myths. Take the infamous Nibiru conspiracy, for example, a rogue planet supposedly on a collision course with Earth, popularized by fringe groups and sensationalized online. But here's the reality check scientists keep emphasizing. Even if Planet 9 is real, it's no apocalyptic harbinger. This potential world orbits so far from the Sun that its gravitational influence on Earth would be weaker than a whisper in a hurricane. The closest it might ever get is still hundreds of times farther than Neptune, practically next door in cosmic terms, but utterly harmless to us. What's fascinating is how these myths persist despite the evidence. Part of it stems from a fundamental misunderstanding of scale. When people hear hidden planet, they might picture something barreling toward us like a cosmic wrecking ball. In truth, Planet 9's orbit, if it exists, would be so vast that a single trip around the sun could take longer than all of human civilization. Its distance isn't just a buffer, it's a guarantee of isolation. Even Jupiter, with its titanic gravity, barely nudges Earth's orbit. A planet 5 times farther out than Pluto wouldn't stand a chance of disrupting life on our world. Scientists aren't just dismissing the myths, they're using them as teachable moments. The frenzy around Nibiru, for instance, highlights how easily pseudoscience can distort legitimate astronomy. But it also underscores why the real search for Planet 9 matters. This isn't about fear, it's about filling in the gaps in our understanding of the solar system's architecture. Every time a researcher points a telescope toward the Kuiper Belt, they're not hunting a boogeyman, they're piecing together a puzzle that could explain everything from the tilt of the sun to the oddball orbits of distant icy worlds. The public's fascination isn't misplaced, though. There's something undeniably thrilling about the possibility that our cosmic neighborhood still holds secrets. It's the same thrill that drove explorers to map uncharted continents or dive into the ocean's depths. The difference is that today's explorers wield equations and infrared sensors instead of compasses and sextants. And while the myths might grab headlines, the real story, the patient, meticulous hunt for answers, is far more compelling. After all, the universe doesn't need doomsday scenarios to be awe-inspiring. Sometimes the truth is strange enough on its own. Science has always been a universal language, and the hunt for Planet 9 is proving just how powerful global teamwork can be. Across continents, astronomers are joining forces, sharing telescope time, data, and late-night coffee-fueled brainstorming sessions to chase this cosmic ghost. In Chile's Atacama Desert, the European Southern Observatory's powerful telescopes peer into the southern sky, while over 8,000 miles away, Hawaii's Mauna Kea observatories scan the same patch of darkness from a different angle. It's like a game of celestial hide and seek, with researchers passing clues back and forth across oceans and time zones. What's remarkable isn't just the scale of the collaboration, it's the democratization of discovery. Amateur astronomers with backyard telescopes contribute alongside Nobel Prize winners, sifting through public data releases for that 1 in a billion anomaly. Online platforms like Zooniverse let anyone with an internet connection join the search, turning planet hunting into a crowdsourced adventure. This isn't just about pooling resources, it's about redefining who gets to participate in cutting-edge science. When the Vera Rubin Observatory's flood of data begins in 2025, the global team analyzing it will span dozens of countries, proving that the cosmos doesn't recognize borders, only curiosity. The technology enabling this collaboration is as groundbreaking as the search itself. Cloud-based databases allow real-time sharing of observations, while machine learning algorithms trained in Tokyo can flag anomalies in images taken from Arizona. Telescopes once jealously guarded by individual institutions now sync their schedules, coordinating observations like a finely tuned orchestra. Even setbacks become shared lessons when one team's lead fizzles out. Their data often sparks a breakthrough for another group halfway around the world. This spirit of unity isn't just practical, it's poetic. In an era often defined by division, the quest for Planet 9 reminds us that some mysteries are bigger than politics, bigger than nations. Whether the hidden world is ultimately found by a veteran astronomer or a teenager combing through public data on a laptop, its discovery will belong to all of us, a testament to what humanity can achieve when we point our collective gaze toward the stars. The hunt for Planet 9 is about to get a turbocharged upgrade, thanks to a new generation of telescopes and technologies designed to peer deeper into the dark than ever before. Leading the charge is the Vera C, Rubin Observatory, perched high in Chile's Atacama Desert like a cosmic sentinel. When it begins its legacy survey of space and time in 2025, this powerhouse will do something unprecedented. Scan the entire southern sky every few nights with a mirror wider than a school bus, capturing details so faint they'd make most telescopes blush. Imagine combing through a haystack not with your hands, but with a magnet tuned to exactly the kind of needle you're looking for. That's the level of precision Rubin brings to the table. Its camera, the largest digital eye ever built for astronomy, could spot Planet 9 within a decade if it's lurking where simulations suggest, turning what's now a hypothesis into a headline. But Rubin isn't working alone. Advances in infrared astronomy are peeling back the veil on cold, distant objects that visible light misses. Telescopes like NASA's upcoming Nancy Grace Roman Space Telescope, set to launch by 2027, will act as heat-seeking missiles for the cosmos, detecting the faint thermal glow of worlds too dark to reflect sunlight. If Planet 9 is as cold and dim as models predict, infrared might be our only shot at seeing it, like spotting a snowman in a blizzard by the warmth of its breath. Meanwhile, AI is transforming the data deluge into actionable clues. Machine learning algorithms sift through millions of telescope images at lightning speed, flagging anomalies human eyes might overlook. It's not just about finding a moving dot. It's about teaching computers to recognize the subtle dance of something massive moving against the stars over years or even decades. The real game changer, synergy. Rubin's relentless sky scans will feed into Roman's infrared eyes, while AI cross-references both datasets with gravitational models to narrow the search. It's a celestial dragnet, with each tool playing a unique role. Even amateur astronomers are joining the fray, thanks to projects that crowdsource analysis of public telescope data. One of history's greatest planetary discoveries might come not from a lone genius with a telescope, but from a global brain trust, a mosaic of professionals, hobbyists, and algorithms piecing together the puzzle. Yet for all this firepower, patience remains key. The outer solar system is vast, and Planet 9, if it exists, could be anywhere along an orbit spanning millennia. But with each technological leap, the odds tilt in our favor. Whether it's Rubin's eagle-eyed surveys, Roman's heat-sensitive gaze, or an AI spotting a pixel out of place, the tools now in play ensure one thing. If there's a hidden giant out there, its days in the shadows are numbered. And when it finally steps into the light, it won't just be a new world we're welcoming, it'll be a triumph of human ingenuity over the universe's best-kept secrets. The internet loves a good doomsday story, and few have captured imaginations or sparked unfounded panic quite like the myth of Nibiru. This supposed rogue planet, often depicted in conspiracy circles as a fiery harbinger of Earth's destruction, has been thoroughly debunked by astronomers. Yet its shadow lingers, sometimes unfairly cast over the legitimate search for Planet 9. Here's the critical difference. While Nibiru is pure fiction, Planet 9, if it exists, operates within the well-understood laws of physics, following a predictable, stable orbit that poses zero threat to our planet. Let's break down why these concepts couldn't be more opposite. Nibiru's myth hinges on a chaotic, plunging path toward Earth, often tied to ancient prophecies or fabricated NASA warnings. By contrast, Planet 9's hypothesized orbit, while enormous, is mathematically elegant, a slow, elliptical loop hundreds of times farther out than Pluto's. At its closest approach, it would still be over 20 times more distant than Neptune, a frozen sentinel so remote that sunlight takes nearly a week to reach it. That's like worrying about a lighthouse on another continent flickering too brightly. Scientists aren't just dismissing Nibiru, they're using it as a case study in how misinformation spreads. When the hypothetical Planet 9 first made headlines, a vocal minority conflated it with doomsday scenarios, forcing researchers to repeatedly clarify the facts. Caltech's Mike Brown, one of the astronomers behind the Planet 9 hypothesis, even joked that his biggest challenge isn't finding the planet, it's convincing people he's not secretly forecasting the apocalypse. The irony, the real science is far more thrilling than fiction. Instead of fear, Planet 9 offers a chance to solve cosmic mysteries. Why do some Kuiper Belt objects cluster like sheep herded by an invisible dog? Why does the solar system tilt? These questions shape our understanding of planetary formation, not tabloid nightmares. What's often lost in the noise is how planetary orbits actually work. Gravity isn't a random force, it's a predictable dance where mass and distance dictate every step. A planet as massive as Earth, even 10 times over, couldn't suddenly veer off course without centuries of warning. Its momentum is locked in by the sun's gravity like a ball on a tether. The very stability that makes Planet 9 so hard to detect also guarantees its harmlessness. Compare that to Nibiru's alleged zigzagging path, which would violate fundamental physics like a car speeding uphill without an engine. The takeaway isn't just to debunk myths, but to reframe the conversation. Planet 9 represents the cutting edge of discovery, where patience and precision replace sensationalism. Every time a telescope scans the outer solar system, it's not hunting a boogeyman, it's testing hypotheses, refining models, and inching closer to answers. And in a world hungry for clickbait, that distinction matters. The universe is wondrous enough without inventing dangers. Sometimes the truth hiding in the dark is more extraordinary than anything we could make up. The hunt for Planet 9 isn't just for professional astronomers with million-dollar telescopes. Some of the most exciting discoveries in space have come from everyday stargazers with a passion for the cosmos. Take the story of Japanese amateur astronomer Masayuki Iwamoto, who in 2019 spotted a never-before-seen comet using nothing but a modest telescope and sheer determination. Or consider the countless backyard observers who have contributed to asteroid tracking, proving you don't need a PhD to play a role in cutting-edge astronomy. This tradition of citizen science is now breathing new life into the search for our solar system's potential hidden giant, turning what could be a solitary scientific quest into a global collaboration. Projects like Backyard Worlds, Planet 9 are democratizing discovery, inviting anyone with an internet connection to sift through telescope data for clues. The concept is simple but powerful. Computers are great at processing vast amounts of information, but human eyes still excel at pattern recognition, spotting that one odd pixel that might indicate a slow-moving world. Volunteers scour infrared images from NAS, a wise spacecraft, flagging anything that doesn't look like a star or galaxy. It's like a cosmic version of Where's Waldo, except the prize could be rewriting astronomy textbooks. Already, participants have identified previously unknown brown dwarfs and peculiar celestial objects, proving the method works. What makes amateur contributions so valuable isn't just extra pairs of eyes, it's diversity of perspective. A retired teacher in Norway might notice something a career astronomer in California overlooks, simply because they're looking differently. This crowdsourced approach also tackles one of the biggest challenges in the Planet 9 hunt: time. Professionals have limited hours on premier telescopes, but amateurs can analyze data anytime, turning downtime into discovery opportunities. Platforms like Zooniverse even gamify the process, letting users compete to scan the most images or earn badges for verified finds. The stakes are high, but so is the excitement. Imagine logging onto your laptop after dinner and becoming the first person in history to spot a faint dot moving against the stars. a dot that could be our solar system's missing giant. It's happened before. In 1846, amateur astronomer Johann Galle confirmed Neptune's existence based on mathematical predictions, using a telescope far less powerful than many backyard models today. Modern tools have only leveled the playing field further, with free software like Stellarium helping enthusiasts learn the sky and online communities sharing tips in real time. Of course, spotting Planet 9 would be tougher than finding a needle in a haystack. It's more like finding a specific needle in a stack of other needles, all while the stack is moving. But that hasn't dampened enthusiasm. From high school students to retired engineers, thousands now routinely comb through data, each bringing unique skills to the search. Some focus on vetting potential candidates flagged by algorithms, while others methodically scan uncharted regions. The beauty of this approach is its scalability. As more volunteers join, the search grid expands exponentially. Even if amateurs don't land the ultimate prize, their work is advancing science in unexpected ways. Many participants have discovered unusual Kuiper Belt objects or oddball orbits that refine our understanding of the solar system's outer limits. These findings help professionals narrow the search, like tightening a net around a fish too elusive to see. And the collaborative spirit itself is transformative, proving that in an era of specialization, groundbreaking science can still be a team sport. Whether Planet 9 is found by a PhD astrophysicist or a night shift worker with a telescope on their apartment balcony, one thing's certain: its discovery will belong to everyone who dared to look. The discovery of a hidden planet in our own solar system would be more than a scientific breakthrough. It would be a cosmic reality check, a humbling reminder that even in our own celestial neighborhood, mysteries still lurk in plain sight. Think about it. We've sent probes to Pluto, mapped millions of galaxies, and yet something as massive as 5 Earths might have been hiding just beyond our gaze. This isn't just about adding another world to the list. It's about confronting the limits of human knowledge. For centuries, we've assumed the solar system was a solved puzzle, its major pieces neatly catalogued. But if Planet 9 exists, it shatters that illusion, proving that the universe still holds cards close to its chest, even in the places we thought we knew best. Consider how often science has rewritten its own rulebook. Not long ago, astronomers believed the Sun revolved around Earth, that Mars had canals, that Pluto was the final frontier. Each correction wasn't a failure, it was progress, a sign that curiosity and humility drive discovery. The hunt for Planet 9 embodies this spirit. It's not about proving we were wrong, it's about revealing how much richer reality is than our assumptions. Every time we peer deeper into the cosmos, we're reminded that the universe operates on a scale that dwarfs human intuition. A planet 10 times Earth's mass could orbit undetected for millennia, not because we weren't looking, but because the darkness is vaster than we comprehend. This search also raises a deeper question: what else might we be missing? If something this significant could evade detection, what other cosmic surprises are waiting in the shadows? The Kuiper Belt, once dismissed as a barren wasteland, is now a treasure trove of oddities, each one a clue that our solar system's history is wilder than we imagined. Perhaps Planet 9 isn't an anomaly but a signpost pointing to a broader truth, that the universe rarely fits into tidy models. The very fact that we're still debating its existence, still scanning the skies for proof, speaks to the essence of science. It's not a static set of facts but a living process, a conversation between what we know and what we've yet to discover, and that's the real gift of this mystery. Whether Planet 9 is confirmed tomorrow or remains elusive for decades, the pursuit itself keeps us intellectually honest. It's an antidote to arrogance, a reminder that the cosmos owes us no explanations. Every anomalous orbit, every unexplained wobble is a whisper from the universe. Look harder, think bigger. The day we stop being surprised by the solar system is the day we stop truly seeing it. So let's celebrate the not knowing, the thrilling possibility that even in our own backyard, the universe still has stories left to tell. Even if Planet 9 remains forever hidden in the solar system's shadows, the hunt for it has already reshaped science and technology in ways that ripple far beyond astronomy. Consider the Vera Rubin Observatory, a groundbreaking telescope built in part to scan the outer solar system for faint, slow-moving objects. Its revolutionary camera, capable of capturing the entire visible sky every few nights, isn't just a tool for planet hunters. It's a game-changer for tracking near-Earth asteroids, studying dark matter, and even monitoring space debris that threatens satellites. The same ultra-sensitive optics designed to spot a dim, distant world could one day give us early warnings of incoming asteroids, protecting billions of lives. That's the hidden power of cosmic curiosity. The tools we build to answer one question often unlock solutions to problems we hadn't even considered. Then there's the software revolution quietly unfolding in observatories worldwide. The algorithms developed to sift through mountains of telescope data for Planet 9's faint signature are now helping doctors spot tumors in medical scans, farmers monitor crop health from space, and climate scientists track melting ice sheets with unprecedented precision. Machine learning models trained to recognize a single moving pixel against a backdrop of stars are being adapted to predict wildfire spread, optimize traffic flow, and even detect counterfeit goods. What began as a niche tool for astronomers has become a Swiss Army knife for the digital age, proving that the pursuit of pure knowledge often spins off practical innovations no one saw coming. But perhaps the most enduring legacy of this search isn't technological, it's human. Every time a high school student joins a crowdsourced planet hunting project, or a college intern helps analyze Kuiper Belt data, the mystery of Planet 9 ignites imaginations. Take the story of a teenager in India who taught herself coding to contribute to the Backyard Worlds initiative, only to later pursue astrophysics after spotting an unusual object in telescope images. Or the university lab in Brazil where students built low-cost sensors to monitor telescope performance, now used in weather stations across the Amazon. These aren't just feel-good anecdotes, they're proof that grand scientific quests act as talent incubators, drawing fresh minds into STEM fields where their creativity can tackle everything from renewable energy to pandemic modeling. The economic impact, too, is often overlooked. The same precision engineering required to grind mirrors for Planet 9 hunting telescopes has revolutionized manufacturing processes for semiconductors and solar panels. Adaptive optics, originally developed to cancel out atmospheric blur in astronomical images, now sharpen vision correction surgeries and improve laser communications. Even the struggle to process petabytes of sky survey data has driven breakthroughs in cloud computing and data compression, technologies that power everything from streaming services to financial markets. It's a reminder that funding fundamental science isn't just about answering cosmic questions, it's an investment in the innovation ecosystem that fuels entire industries. History shows this pattern repeats. The math used to discover Neptune birthed modern ocean navigation. Apollo-era miniaturized computing gave rise to smartphones. Now the Planet 9 search is writing the next chapter, proving once again that when humanity reaches for the stars, the tools we grasp along the way often change life on Earth long before the original goal is achieved. Whether or not we ever find this celestial ghost, its gravitational pull on science and society is already undeniable. a testament to the unpredictable rewards of simply daring to look up and wonder. The idea of a hidden planet lurking at the edge of our solar system isn't just a scientific puzzle, it's a cultural lightning rod, sparking creativity from textbooks to blockbuster films. There's something deeply human about the notion that our cosmic backyard might still hold secrets, a theme that's fueled storytelling for centuries, long before astronomers crunched the numbers on those 22 oddball Kuiper Belt orbits. Mythologies whispered of unseen worlds, from the celestial spheres of ancient Greece to the counter-Earth imagined by Renaissance scholars. Today, Planet 9 slots neatly into that lineage, a modern myth in the making, blending hard science with the timeless allure of the unknown. Look at how this mystery has already seeped into pop culture. Documentaries like The Planets dedicate entire segments to the hunt, framing it as a high-stakes detective story with telescopes instead of magnifying glasses. Sci-fi authors, meanwhile, have run wild with the possibilities. Imagine a frozen super-Earth harboring alien ruins, or a rogue planet carrying dormant life across the galaxy. Even video games like Destiny and Mass Effect feature shadowy worlds on the solar system's fringe, proving how powerfully this concept resonates. It's not just about the science, it's about the narrative tension between what we know and what we've yet to discover, a theme as old as storytelling itself. The cultural weight of Planet 9 goes deeper than fiction, though. It's become a symbol of scientific perseverance, a reminder that exploration isn't just about rockets and rovers, it's about patience, collaboration, and the willingness to question assumptions. Kids doodling the solar system in classrooms now add a question mark beyond Neptune, a tiny act of rebellion against the idea that everything's already mapped. Museums feature interactive exhibits where visitors search for the hidden planet, turning abstract astronomy into a hands-on adventure. Even the language we use reflects this, calling it Planet 9 instead of a dry catalog number makes it feel personal, like a character in an unfolding saga rather than a data point. What's fascinating is how this mirrors past discoveries. When Pluto was found in 1930, it captured the public's imagination in ways Uranus or Neptune never had, becoming an underdog hero in children's books and cereal box ads. Planet 9, with its ghostly presence and earth-shaking potential, could eclipse even that, especially if it's found not by a lone genius, but by a global team of pros and amateurs combing through data. The story writes itself, a digital age treasure hunt where the prize isn't gold but knowledge, and the map is written in gravity's faintest whispers. Ultimately, whether Planet 9 is confirmed or debunked, its cultural footprint is already indelible. It's become shorthand for the thrill of the hunt, the joy of not knowing, and the quiet hope that the universe still has wonders left to share. In a world where so much feels mapped and measured, that's a rare gift, a reminder that curiosity, not certainty, is what drives us forward. And maybe, just maybe, the next time you glance at the night sky, you'll catch yourself squinting at the dark between the stars, wondering what else might be out there, waiting. Science thrives on debate, and the hunt for Planet 9 is no exception. While the evidence is compelling, not every astronomer is ready to declare victory. Some point out that the strange orbits of those 22 Kuiper Belt objects might not be cosmic breadcrumbs leading to a hidden world. They could simply be statistical noise, the kind of random clustering that happens when you're dealing with limited data. Imagine flipping a coin 22 times and getting 16 heads. Unusual, absolutely. Impossible, not quite. That's the heart of the skepticism. Extraordinary claims require extraordinary evidence, and for some researchers, the current data isn't quite extraordinary enough. Take the case of observational bias. The Kuiper Belt is vast, and our surveys have only scratched the surface. Most discoveries come from telescopes pointed at specific regions, meaning we might be seeing patterns that don't truly exist. It's like trying to map a forest by only examining a few trees. If those trees happen to lean in the same direction, you might assume the whole forest grows at an angle, when in reality, it's just a quirk of your sample. Critics argue that until we've mapped a larger, more random slice of the Kuiper Belt, the clustering of these odd orbits could be an illusion. Then there's the gravitational tug-of-war theory. Some researchers propose that the combined pull of countless smaller, undiscovered objects, dwarf planets, icy rubble, or even a diffuse cloud of debris could collectively nudge the orbits we see. Think of it like 100 tiny magnets scattered on a table, each exerting a faint pull on a nearby paperclip. Alone, their force is negligible, but together they might just bend the clip's path. The math is tricky, though. To mimic the influence of a single massive planet, you'd need an implausibly dense swarm of objects, all perfectly positioned. It's not impossible, but as one astronomer put it, Occam's razor suggests we're not missing 1,000 tiny things, we're missing one big thing. What's fascinating is how this skepticism fuels progress. Every critique forces Planet 9 proponents to refine their models, test new scenarios, and dig deeper into the data. When a team at the University of Michigan ran simulations without a hidden planet, they found that under very specific conditions, like a slightly more massive Kuiper Belt or a rogue star's ancient flyby, they could sorta reproduce the odd orbits. The results weren't perfect, but they were enough to keep the debate alive. That's how science self-corrects, not by dismissing ideas outright, but by poking at them until only the strongest survive. And let's not forget history's lessons. In the 1980s, astronomers were convinced they'd found a 10th planet dubbed Planet X, based on irregularities in Pluto's orbit. Better data later revealed those irregularities were measurement errors, not gravitational hints. It was a humbling reminder that even the smartest minds can be led astray by incomplete information. Today's Planet 9 hypothesis is far more robust, but the cautionary tale lingers. The beauty of this debate isn't just about being right or wrong, it's about the process. Every paper, every counterargument, every new telescope scan adds another layer to our understanding. Whether Planet 9 is confirmed or debunked, the search has already expanded our knowledge of the solar system's outer reaches, revealing a wilder, weirder frontier than we ever imagined. And that's the real triumph, not just finding answers, but learning better ways to ask the questions. The mystery of those 22 rebellious Kuiper Belt objects is more than just a scientific challenge. It's a cosmic wake-up call, a reminder that even in our own celestial backyard, the universe still holds cards close to its chest. Whether these odd orbits ultimately lead us to Planet 9 or force us to rewrite the rules of solar system dynamics, one thing's certain: the journey itself has already transformed how we see our place in the cosmos. Think about it, we've mapped galaxies billions of light years away, yet right here, in the frozen fringes of our own solar neighborhood, something massive might be hiding in plain sight. Its gravity nudging distant worlds like an unseen puppeteer. That's the humbling beauty of astronomy. The more we learn, the more we realize how much we've yet to discover. For centuries, humanity believed the solar system was tidy and complete, its major players all accounted for. Then came Neptune, Pluto, and now perhaps Planet 9. Each discovery peeling back another layer of cosmic complacency. What's thrilling isn't just the potential of finding a new world, but the way this mystery exposes the gaps in our understanding. Those 22 peculiar orbits aren't just anomalies. They're invitations to dig deeper, to question assumptions, and to embrace the possibility that reality is stranger than our models predict. After all, the most groundbreaking discoveries often begin with someone noticing a tiny detail that doesn't quite fit. And here's the best part: you don't need a telescope to be part of this story. Every time you glance up at the night sky, you're participating in the same timeless human quest that drove Galileo and Copernicus. The hunt for Planet 9 isn't just for scientists in lab coats, it's for anyone who's ever wondered what's lurking in the dark, just beyond the edge of the map. Who knows, the next big clue might come from an amateur astronomer's backyard observation, a student's data crunching, or even an algorithm sifting through old telescope images. That's the magic of science. It's a collective adventure where every curious mind has a role to play. So stay curious, keep looking up, and remember, the universe loves a good plot twist. Whether Planet 9 steps into the spotlight or the mystery takes an unexpected turn, one thing's guaranteed: the cosmos will keep surprising us, and when it does, you'll want a front row seat. For more deep dives into space's biggest secrets, hit subscribe and join us as we unravel the universe's greatest puzzles, one discovery at a time. The next chapter of this cosmic detective story is yours to follow.